Hello, my name is Rajbir and I'm from Group 25. My other group member's name is Gurditt and welcome to our AWS security overview presentation. Our project statement is showcasing different ways cloud computing can be vulnerable and describing ways to guard against them. This led to our main accomplishments focusing on discovering how to compromise and secure the AWS cloud against broken authentication and injection. So we broke down our project into two aspects. The first aspect focused on compromising and second on securing. We thought in order to learn how to secure the cloud, we would need to learn the security risks. The two main security risks we picked were broken authentication and injection. Having picked those, we then spent time trying to compromise the AWS cloud. We did this by creating a script to crack an AWS access key. And although we were able to create a script, it would take a substantial amount of time for the script to actually brute force crack an AWS key. This is due to the complexity and length of an access ID and secret access key that AWS generates. Testing the security of an AWS cloud database, AWS uses DynamoDB as its NoSQL database, and we explored possible options to try to inject code into the database. We couldn't successfully inject code, but we were able to get items from the database. After this, we investigated how to protect an AWS cloud against these security risks. We explored how to monitor what is happening on an AWS account, mainly focusing on odd behavior such as large downloads or deletes in the S3 container, multiple failed authentication attempts of an IAM user, and how to detect a brute force attack on cracking access keys. We also learned what steps a developer must take to secure an AWS database, investigated a tool AWS offers to protect against injection called WAF, which stands for Web App Firewall. And so before I discuss why this is important, I just want to bring up some past AWS data breaches. So in 2019, Facebook had 540 million user records exposed on an AWS server. And another breach that happened was 49 million Instagram influencers, celebrities, and brands had their private contact information exposed due to data left unprotected on an AWS database by an Indian company called Chatterbox. In both these instances, the breaches were caused by neglect on the AWS customer. And research done by Gartner predicts that through 2025, 99% of cloud security failures will be the customer's fault. As future cloud developers, it is important that we are educated on how cloud security works, where the cloud is vulnerable, and what tools are available to secure the cloud. So now to go on to our major accomplishments. We had two. The first one is how to secure against broken authentication, and the second was how to secure against injection. So before I explain the first accomplishment, I just want to go over what cloud aspects were used. I'm not going to go into too much detail on AWS Lambda, AWS IAM, and Amazon S3, as we already discussed those in class. So the three that are new here are AWS CloudTrail, Amazon CloudWatch, and Amazon SNS. So AWS CloudTrail tracks every aspect of AWS and logs this information. The logs are set up to easily be audited or monitored, stored in an S3 container, and integrated with CloudWatch and Lambda. CloudTrail also identifies activities you might want monitored. A trail created by CloudTrail can use CloudTrail insights to monitor unusual S3 behavior or multiple failed authentication attempts. Each insight requires its own trail, and in the free tier you only get one trail, and so I use that trail to connect to CloudWatch instead of to CloudTrail Insights, as I wouldn't have been able to investigate enough monitoring avenues. So then Amazon CloudWatch acts as a monitoring service that provides actionable insights and allows storage of logs created by CloudWatch. You can use CloudWatch to detect unusual behavior in an AWS account, set alarms, visualize logs and metrics side by side, take automated actions, troubleshoot issues, and discover insights. In the free tier, we can set up to 10 alarms and store up to 5 gigabytes of log data. So I use CloudWatch to filter the logs created from CloudTrail and then action notifications and Lambda function triggers. And then we have Amazon SNS, which is a simple notification service. So what Amazon SNS does is it enables message filtering and fan out to many subscribers, including Amazon SQS, AWS Lambda, and HTTP and HTTPS webhooks. Additionally, Amazon SNS fans out notifications to end users via mobile push messages, SNS, and email. So in the free tier, we have unlimited services, unlimited messaging to SQS and Lambda, and we can have up to 1,000 free emails. And so what I did was create an email template, and we needed to use SNS to actually connect CloudWatch to Lambda. So an SNS topic and subscription had to be connected to do that connection for each alarm that needed to be connected to a different Lambda function. So the other three following the AWS Lambda, Amazon S3, and AWS IAM were discussed during the semester. So we're just going to explain what I was doing with them. So with AWS Lambda, I created functions to automate response to broken authentication. With Amazon S3, I used it to store CloudTrail logs and CloudWatch logs, and to basically test that my CloudWatch alarms are working. And for AWS IAM, basically I needed IAM users that I could use to, again, test my CloudWatch alarms. So to go into the first major accomplishment, which was how to secure cloud against broken authentication. So broken authentication, as described by OWASP, is the use of manual or automatic methods to gain control of systems by using vulnerabilities in the system's authentication process. These vulnerabilities in authentication in AWS are around access keys, how they're protected, and how they're managed, IAM users, so how are they managed and what type of passwords are allowed, and allowing brute force attacks to break an access key or IAM user login. So in order to secure against these vulnerabilities, what I did was first figure out how to monitor them. And so the monitoring happens with CloudTrail and CloudWatch. And then you can either get notified about these vulnerabilities or take action. So then this required CloudWatch to set CloudWatch alarms that can trigger an email notification or trigger a Lambda function. And the Lambda function would act as an automated response to like the broken authentication that just happened. So now I'm going to give a brief tutorial about how to set up a CloudTrail and CloudWatch, as these were the main topics I had used to figure out how to monitor security risks in AWS Cloud. And so for the tutorial, the idea I'm going to be thinking about is how do you monitor a mishandling of S3 container. And so before I get into actually the tutorial part, I'm just going to talk about some of the services you already need to have set up in order for the CloudTrail and CloudWatch to work. So the first thing you need is some IAM rules. So you have the two main rules I need are this CloudTrail one and this Lambda function one. The CloudTrail one basically allows CloudTrail to send information to CloudWatch, and then the one for my Lambda function is so that the Lambda function can access S3 and IAM roles. And then we have our SNS topic, which is for my Lambda function. So in order for CloudWatch to speak to Lambda, it needs a SNS subscription it needs a topic, and then the topic has to have a subscription to the Lambda function. So here, this subscription subscribes this topic to my Lambda function. So the Lambda function that I created, this part isn't necessary, but this is just so I could see what kind of automation I was able to do. So the function gets triggered from the SNS that's attached to the CloudWatch alarm, and it deletes access keys. It gets a list of blobs mishandled in the last 15 minutes, and it removes all root access to S3 storage. So again, this Lambda function isn't really necessary. It's only if you do want to implement an automated response to a CloudWatch alarm. And then we have my S3 buckets. You can have as many buckets here. This is just really needed to make sure that the alarm is actually triggered and to do some help with some testing. Now to get to the tutorial. We're going to start by creating a trail. All this is fine. Here we just want to select all buckets so that we can actually monitor that. And then we want to put the logs into a bucket I've already created. I'm going to hit create. We need to go back to this trail to actually link it with our CloudWatch group, which I've already created. Hit continue. Now, it usually takes about 10 seconds for the account to get verified. So we're going to do that, then we'll go to the actual CloudWatch to make the alarm. So all this is doing is allowing CloudTrail to access CloudWatch, and that's why we need that role that I talked about earlier. So while that's happening, we'll just go to Chun-Li, hit create metric filter. Here, the filter pattern I've already created. Basically, it works as an if statement to go through each of the events, and if the event matches one that is bad as assigned by the filter pattern, then I can trigger my alarm. So we assign the metric. We'll just call it this for now. And then we want to create an alarm. So we just want to go back here. Yeah, so here it's been linked already. So for the alarm application, it should be fine. So the condition here, since we're just going to be testing, I'm going to hit 2. So this means when 2 things have been mishandled in S3 container, our alarm will be triggered. So once the alarm is triggered, we actually want something to happen. So we want an email to be sent out. Send. We're going to just create a new topic so I can show what a subscription email looks like. And I'm just going to be using my University of Guelph email. Okay, so create the topic, and then we want to add another notification, which is for that SNS I talked about earlier. This will actually link CloudWatch to your Lambda function. And once that's done, we'll hit next, and we'll hit next here to just name it, and then hit create. So once the alarm has been created, it can take up to 5 minutes for the alarm to reach OK state. Once it's in OK state, then the alarm can actually start triggering actions. But now we'll move on to major accomplishment number 2.
Now to explain our findings with DynamoDB and SQL injections. SQL injections are pieces of code that are added into the query by the use of some user field. These were a great threat to the databases in the past, but they're mostly obsolete now. Part of the reason why is the existence of the NoSQL databases. NoSQL behaves differently. They do not run SQL, hence the name NoSQL. They instead use JSON query. This does not mean they're invulnerable to injections, as they still certainly are, but the attackers will require more than just SQL knowledge to pull off the injections. This is where the web application firewall comes into play. The AWS firewall is a paid service, so we didn't get to explore it in detail, but we definitely understand its uses and the applications for it. When you create a database, you can get it to sync up with a load balancer, like the one Amazon provides, Elastic Load Balancing. This way you can create a web application firewall that is applied to the load balancer, or if you have an API gateway, you can apply it to that instead. This is one of the good aspects of the web firewall, how easy it is to deploy to any application on the cloud. In terms of security, it provides protection against most common attacks, including SQL injections, distributed denial of service, and also lets you monitor the traffic to trigger the CloudWatch alarms, which we will get into later. But in order to use the web application firewall, you need to create rules that describe how you want your application to be handled. Now comes in another feature of the web firewall, Amazon's pre-configured rules. As many of us already worked on the AWS and its roles, we know that Amazon provides many pre-configured rules, so we won't have to create them ourselves. And you can always find one to your needs to get things started. This is also the case in terms of web firewall. It comes with these rules so you can at least protect yourself against the common attacks, and you can later revisit it and change it to your needs. Example of this is setting up a database with sensitive information. As a developer of the code, you know that at any given point in time, the database should give one or more scan results when asked about password or credit card information. With this knowledge, you can set up the web firewall in combination with the CloudWatch to alert itself when the query returns over the expected amount. As we described before, CloudWatch will send notifications when it is in an alarm state, and the developers can take action to further protect the resource in case of an ongoing attack. Now for a demonstration of the database. I will start it off by explaining how Dynamo database formats its payloads. In terms of inputs, there are certain types of inputs that the cloud allows, and this is the way it structures its inputs. As you can see, the type is given first and the value after it, and it is all encapsulated in the attribute value. Above this, you can see all the types that are available to use, including the number and the string. This is far easier to inject code into compared to the other ones. Next, we have the injection itself, and to explain it, I will start with SQL injections. Now, think of a scenario where the user enters in their ID and gets a list of products that they have put in their carts. This is the SQL equivalent, and the input number is here. The way SQL injections work is that they add code into these inputs and have it run on the target. In this case, I can input code after the ID, so the comparison will always be true. This causes the list to return all the products from all users that are in the database. Another example is with using strings. Since you can escape the first string, you need to somehow close the next one. And you can simply do that with commenting it out and placing some kind of condition before it to run your injected code. In this case, I'm just placing a true condition to return everything. I explained this so we can understand why NoSQL injections are a lot harder than SQL. The payloads are structured very differently, and the attacker has to somehow be able to inject code into it while making the code run. The attribute value list is contained within key condition expressions and query filters, and to inject code into these values and have the query not fail is beyond my capabilities right now, so I cannot demonstrate a NoSQL injection. But with this knowledge, the attacker will gain enough resources and combine it with his own hacking experience to potentially attack a NoSQL database like DynamoDB. When it comes to defending the database, you can use the same steps as we demonstrated before with CloudWatch and apply it to DynamoDB instead. When it comes to the future work, we would like to explore more Amazon provided security services like Gurditt. It is a threat detection service that automates the whole process with rules that are set by Amazon and its third parties. From our understanding, the protection is given to the entire cloud, and the logs that it generates can be migrated to other services like CloudTrail, which could be convenient to some users. We would have liked if we had more access to the web firewall. We could get some practical uses out of it as well. As for our project, CloudWatch worked well. We managed to set off alarms and have it emailed to our accounts. But as I explained before, NoSQL injections are incredibly hard to do, and we were unsuccessful in them. We were lucky to learn about CloudWatch early, as it was extremely helpful in implementing procedures to secure our AWS accounts. The web interface was easy to use, the service was able to integrate with Lambda, and the alarm actions allowed us to be notified when our AWS accounts were being compromised. It would have been useful if we were willing to spend some money on our accounts so that we can spend it on CloudTrail, giving us access to more than one CloudTrail service. This would allow us to make CloudTrail insights, as we were rejected by one free trail. We didn't spend time implementing CloudTrail insights, but AWS offered inbuilt insights that can track spikes in resource and bursts in IAM actions, and the insights that provided information on maintenance activities. These built-in insights covers few other alarms that we created with CloudWatch. This is it for our presentation. We hope that you enjoyed it and got some useful information from it.